Hello, Pre-Algebra students. This is Chapter 8.6, Part 2, which covers the two brief focus on functions sections of our textbook, domain and range, and interpreting scatter plots. Let's work through these concepts. Functions can be classified as either discrete or continuous. A discrete function has a graph that is made up of isolated points, such as the example shown here. A continuous function has a graph that is an unbroken line, such as the example here. Let's work through an example where we'll graph and then classify a function. Let's begin by graphing the function y equals 2x plus 1 with the given domain. Remember, the domain is the set of allowable x values or inputs for our equation. So if our domain is -1, 0, 1, and 2, we know we're going to be creating a graph with 4 distinct points. Let's go ahead and do that. First, let's create a table with the values. If x equals -1 and we insert it into this equation, then y will also equal -1. If x equals 0, y will equal 1. If x equals 1, y will equal 3. And if x equals 2, y will equal 5. All right, let's go ahead and plot those ordered pairs. So our first is -1, -1. Then we have 0, 1, 1, 3, and 2, 5. All right, I am not going to draw a line to connect these points. Why? The domain specifically says that the values allowed for x are -1, 0, 1, and 2. If I draw a line to connect the points, I'm communicating that any point on that line is an allowable value for x. Therefore, we cannot connect the points. This is a discrete function with 4 specific data points. The range of this function, remember range is our set of y values. So our range is going to be equal to -1, 1, 3, and 5. Let's work another example. We're going to work with the same equation. However, we're going to establish a new domain. For y equals 2x plus 1, we're now going to graph the domain where x is greater than or equal to 0. Let's go ahead and create a table point and then plot a few points for this. So we'll begin with x being equal to 0, because that's our first allowable x input in our domain. So 0 would give us a value of 1. And then let's just work up for a few values here so we have a few points to plot. All right, if x is equal to 1, then y is equal to 3. If x equals 2, y is 5. If x equals 3, y is 7. If x equals 4, y is 9. All right, let's go ahead and graph these points. So we have 0, 1, 1, 3, 2, 5, 3, 7, and then I actually can't even plot our last point because we don't have space on our graph. Now I am going to connect these points to create a linear function that is continuous. Why can I do that? Because our domain includes all values greater than or equal to 0. It doesn't say they have to be integers. So the value of 1.5 is valid. The value of 2.5 would be valid. So we can draw the line and include those points on our visual representation of the equation. So notice that y values increase from 1 as x increases from 0. That means we can define our range as y being greater than or equal to 1. Okay? Let's move on to the next example. Let's work with this real-world example of a function. We're going to write an equation for the function that's described here, and then we're going to tell whether the function is discrete or continuous. Then we'll answer the questions that I posed to you. All right, the length of a locomotive for a freight train is 47 feet. Each freight car has a length of 53 feet. The total length of the train is a function of the number of freight cars that make up the train. How many cars does a freight train have if the total length of the train is 895 feet? All right, let's begin by creating our equation. First, we're going to let x represent the number of freight cars. And we're going to let y represent the total length of the train. The locomotive is 47 feet long, and each freight car is 53 feet long. So the equation we'll create will be y equals the total length of the train equals 47, the length of the locomotive, plus 53 times x, the number of cars. Our domain is going to have to consist of whole numbers only. We cannot have a part of a freight car. So our function must be discrete because our only possible values are 0, 1, 2, 3, 4, 5, 6, right? We can't have 5.5 freight cars. All right, so now that we know our function is discrete, and we know that our domain is equal to whole numbers greater than 0, which we would indicate like this. Now we can go ahead and solve. So we want to find out how many cars the freight train has if it is 895 feet long. All we do now is substitute and solve. So 895 will equal 47 plus 53x. 53x is going to be equal to 848. X equals 16. So the freight train has 16 cars. Press pause, open up your textbook to page 447, and please solve these 7 practice problems there that relate to domain and range of a function. When you're finished, come back and we'll take a look at interpreting scatter plots. Now let's take a look at scatter plots together. A scatter plot may suggest whether an association exists between 2 sets of data. We're graphing x as it relates to y, and there are 3 possible relationships that may develop. Scatter plots show trends in data, and an association between 2 sets of data results in what we call clustering or gathering of data points along a line. So there are 3 basic patterns you'll see emerge. The first is a positive linear association. That means that as x increases, y is also increasing. You might also see a negative linear association, which shows that as x increases, y tends to decrease. An example of that might be if you're measuring gas in a gas tank. As you travel miles, x, the amount of gas, y, will decrease. And then the final option is that there's no linear association. The points don't show any particular pattern of a relationship between x and y. Scatterplots are really useful for identifying what we call outliers. An outlier is a data value that's really widely separated from the rest of the data in a data set. That can be really useful to identify, particularly in scientific studies. Let's analyze a scatterplot together to see what we can figure out from it. This table shows the age and price in thousands of dollars of several used cars. We are going to create a scatterplot of the data. We're going to identify any outliers and then describe the association. So I'm going to go ahead and show you the scatter plot that was drawn in the book. We'll skip the step of actually plotting the points. I know that you know how to do that. Okay, here's the plot. We're letting the x-coordinate represent the age and the y-coordinate represent the price of the car. The resulting ordered pairs are plotted here. Then a best fit line was created. Remember, we create that best fit line by trying to balance the number of points above the line and below the line. And in this case, we actually have a point that the line travels directly through. Then let's identify our outlier. You see this point way out here? $7,000 and $28,000. That doesn't fit the rest of the data. Finally, we're going to describe our relationship as a negative linear relationship. As x increases, y decreases, or as the age of the car increases, its value decreases. Now we're going to examine a data set that clusters around a curve. It's called a non-linear association. This table shows the age and the yearly income in thousands of dollars of several adults. We're going to make a scatter plot of the data and then describe the association. Here's the plot of the data points, where x represents the age and the y-coordinate represents the yearly income. We can't draw a best fit line because the line won't lie close to all of the data points. So this isn't linear. However, we can draw a curve through the clustered data points where about half of them are above, about half are below, and some fall on the line. So this data has a nonlinear association. Let's wrap up this lesson by completing the practice problems on page 447B of your text. There are 3 examples where you'll need to create a data plot, identify any outliers, and then describe the association between the data you've placed on your scatter plot. I'll see you tomorrow to do more practice with this, and thanks for your hard work today.